Welcome back, class. I'm Mr. Teacher with the SAT Math video guide. Let's get started on finishing test number 4. So we're now on number 7. So the question reads, positive integers x, y, and z satisfy the equations x to the negative half is equal to 1/3 and y to the z is equal to 16. If z is greater than y, then what is the value of x plus z? Alright, so first let's work on just the x. So how do we get rid of the negative half power? Well, we need to try and change it to a power of 1, and if you heard that, I'm sorry. It's just I kept my phone off of silent. But so to turn negative half into 1, you would need to multiply it by -2. So raise x to the negative half to the -2. So the negative half times -2 will be equal to -2/2, which is equal to 1. So this will be equal to 1/3 to the power of -2. Don't worry about that now. That can be easily solved now. So just x is equal to 1/3 whole raised to the power -2. So if you remember how to turn negative powers into positive ones, you know that if we put this entire thing under a 1, then it'll fix the entire thing in the sense that, the power turns positive. So 1/1/3 raised to the power 2 will be equal to 1/1/9. 3 squared is 9, and 1 divided by 1 divided by 9 is equal to 1 times 9/1, which is equal to just 9. So x is equal to 9. We're already filling up this page. Okay, so let's do this. So do this. Alright, so now let's try and find y and z. So they told us that z is greater than y, and this is the only way we'll be able to solve this. Now think about it. They are integers, so there are only two possible integers that can fit here, 2 and 4, in either position. It can be 2 to the power 4 is equal to 16, or it can be 4 to the power of 2 is equal to 16. Now, in this case, it needs to be 2 to the power of 4, as z has to be greater than y, so z would be equal to 4. Z would be equal to 4. So 2 to the power of 4 would be equal to 16, which is true, and therefore z is equal to 4. Now we need to know x plus z, which is just equal to 13. And that is choice D. So now, next problem, number 8. So in red, and it's a graph. So let's draw this graph really quickly. There we go. 4, 0, 8, 0, and a semicircle. I could do it better, but that's roughly what it is. Okay, so in the semicircle above, the center is at coordinates 4, 0. Which of the following are x-coordinates of 2 points on this semicircle whose y-coordinates are equal? Okay, so now for this, we need to know about a little bit about symmetry, specifically symmetry of a circle. So, so you can see that if, for instance, we go like 1 point to the left, so this would be 7, 0. The height would be over here. Okay? Now, this is also approximately, it's not, you won't be able to see it in this picture because I couldn't draw the circle, but in the book you will see that if you go that length, this is equal to approximately 1, 0. So now you know in which x values would the y value be the same. So there is x value of 0 and x value of 8, because the y value would be 0 in both cases. Then there is 1 and 7, 2 and 6, 3 and 4. So those are the possible pairs. In our answer choices, the only answer choice that contains any one of these numbers is choice C. And so that is the correct answer. So remember, a circle is pretty symmetric as you can really get. So number 9 now, if p is an integer and 3 is the remainder when 2p plus 7 is divided by 5, then p could be what? So the equation is 2p plus 7 divided by 5. Now, the easiest way to do this is to use your answer choices and plug them in really quickly, because they're small numbers anyway, so you can do it pretty quickly. Let's start with choice A, which is 2 for p. So 2 times 2 plus 7 divided by 5. 2 times 2 is 4, plus 7 is 11, and divided by 5, so that will be equal, that will have a remainder of 1, if I'm not suddenly mistaken. Yeah, a remainder of 1. And now that doesn't work, because the remainder has to be 3. So A is not the correct answer. Let's try B with 3. 2 times 3 plus 7 divided by 5. This will be equal to 2 times 3 is 6 plus 7, 13 divided by 5, which should have a remainder of 3. And that is, therefore, the correct answer. Let's go over to number 10, to Miss Stacy, who has an interesting story to tell us. She noted that she is both the 12th tallest and the 12th shortest student in her class. If everyone in the class is of a different height, how many students are in the class? So this is one of the most common tricks of the SAT we've seen so far. It's just that it'll try and make your brain assume an answer really quickly just at face value. So the answer, if you aren't careful, you might answer choice C as 24, as 12 plus 12. However, let's go over it a little bit. Let's notice the differences. So Stacy noted that she is both the 12th tallest. Now, 12th tallest, that means there are 11 students shorter than her, because she is the 12th tallest. And then she's the 12th shortest student. So there are 11 students taller than her besides her. And then, of course, there's Stacy herself. And so there are 23 students in the class, which is choice B. Just remember to count Stacy at the end as well. We can do one or two more. So let's do number 11, shall we? Right on the same page. So the quadratic function g is given by g of x is equal to a times x squared plus b times x plus c, where a and c are negative constants. Which of the following could be the graph of g? Alright, so g of x is equal to ax squared plus bx plus c. And a and c are equal to negative constants. So, if you don't understand if you get a little confused, so for instance, if we add a negative sign to a in this case, it would turn positive since the number was negative in the first place. But anyways, so let's review some parabolas, I guess. So let's take this graph and examine it a little bit. So the first number determines whether the parabola faces upwards or downwards. If it's positive, then the curve is upwards, or it opens up upwards, and if it's negative, it opens up downwards. Now let's look at the last number, c. That determines where it is on the y-axis. If it's a plus, then the vertex of the parabola, whether it opens up or down, opens from here, above the origin. And if it's negative, then it doesn't matter also whether it opens up or down, but its vertex is under the origin, so a negative y value. So in this case, both of them are negative. So our graph would sort of look, let's divide that. Our graph would look something like this. It opens downwards and has a negative y value, so negative y value vertex. So it should look something like that. The only one that looks at least a little similar to that is A. Alright, we'll do one more problem and we will be done for today. So, number 12. Actually, I won't be done for today. I'm going to make another one. I'm going to finish chapter 4, test number 4 today. And you might get it today as well, or it'll go out tomorrow. So, also there are these points, random points, Q, and somewhere over here, R. Alright, so, figure not drawn to scale. In the figure above, ABCD is a rectangle with BC equal to 4, so AD is also equal to 4, and AB equal to 6, so AC is also equal to 6. Points P, Q, and R are different points on a line that is not shown, that is parallel to the line AD. Points P and Q are symmetric about line AB, and points Q and R are symmetric about line CD. Then what is the length of PR? Alright, so I'm going to use a different color to draw this line so I can show it a bit better. Alright, that's a horrible bright green, but you know, it's fine. So, points P and Q are symmetric about line AB, so this is equal to this. Points Q and R are symmetric about line CD, so this is equal to this, at least, like, for that to be the boundary, so like that. Okay, so, and we know the length of the rectangle is 4. Now, obviously it's not drawn to scale, so you might be wondering, so how do we find the measurements anyway? So, I'll show you this. These points are symmetric about the rectangle, really. So, this line plus this line is equal to 4, if you've noted by now. And this small line is symmetric to this line. So that is also equal to whatever that is equal to. Now, this line is also symmetric to this line. So this small line plus this small line is equal to 4, really, because it's symmetric, just like this one and this one. So that's equal to 4. The line inside the rectangle is equal to 4. You add them both together and you get 8, which is choice B. That is the length of line PQR. Line PR. So I hope this helped you with your SAT preparation. We will be finishing this test in the next video. So until then, take care.